The question I'd like to start with today, what is Common Core, is fairly factual. The question in gray that hides behind it, is math a liberal art, is in gray because it's not synonymous with the question of what is the Common Core, but it will thread through the conversation today, and I hope later as we speak after the presentation. Those of us who were educated in the liberal arts tradition spend a lot of time thinking about its power, with the result that we can eventually become confused about such basic questions as to whether math is a liberal art. So, well, I hope to get to that by the end, but let's dive in. In talking about the Common Core, it is, I find, well to start off with what it is not. It's not a textbook or a curriculum. It's not a test. There will be math today, but it's not a test. It is not a suite of accountability policies. It's not a suite of high school graduation policies. It's not a suite of college admission policies. What it is, humbly, is a list. The elements of the list are expectations that we might like to see as outcomes of a good math education. So here's one. Fluently add and subtract multi-digit whole numbers using the standard algorithm. That's the one we remember. You stack the numbers and work from right to left and carry the one. Here's another one. Recognize that in a multi-digit whole number, a digit in one place represents 10 times what it represents in the place to its right. So for example, 700 divided by 70 could be a problem in long division, or it could be something we know is 10 because we understand what the 7 in 700 means and what the 7 in 70 means, the 10 times as much. It wasn't usual in previous state standards to mention the important ideas in school mathematics by name and to set them as expectations. Here's a third one. Solve word problems involving multiplication of a fraction by a whole number. So each person at a party eats 3/8 of a pound of roast beef. 5 people at the party, how much roast beef is going to be needed? These three selections from the Common Core, one of them is about skill and calculation. One of them is about the understanding of mathematical ideas. Another one is about problem-solving power. I list them here, and I linger over them because I find it's hard to be understood. I'm going to talk a lot about the ideas of math, but I don't want to rush past this first one, as homely as it is, about adding numbers using the standard algorithm. The liberal arts are always grounded in disciplinary excellence, and part of being excellent in math is being able to get the answer. One nice thing about having a list, there are codes attached to these things. You can Google them. Worksheets, activities. If you Googled 5NF1 5 years ago, I don't know what you would have gotten. It's technical specifications for an airplane or something. Now there are lessons, school districts putting things up, nonprofit organizations putting problems associated with fractions with unlike denominators, teachers posting things. It's not a disconnected list. It's not a jumble. It's an outline of a discipline. And when you outline a discipline, it's like a skeleton. It has joints. It has connections. So at achievethecore.org/coherence map, we can see some of those connections between the elements of the list. So look at 5th grade. Let's go find that fraction expectation. It's over there in fractions. Click on that. There it is, add and subtract fractions with unlike denominators. We can map it. See for which things is it important in later grades. What else is it connected to in the current grade? What does it depend on? A student is having trouble adding unlike denominators. Are there precursors that we should talk about with that student? We can back up to look at those. So here's a 4th grade fraction standard about understanding what equivalent fractions are. I can map that and see it in context. If I click into it, also, I can see a math problem that I might include in my lesson plan. Other resources for that. Let me do some before and after. Here's a fraction problem, everybody's favorite subject. This is a test question from one of the more highly regarded tests of mathematics from the state math test before the Common Core. So what fraction of the coats are white? There are 2 white and 3 shaded gray. So writing the answer, you write a 2 on top of a 3, and you get the answer right. Oh, I'm sorry. No, you don't. But I'll bet kids do. It's a 2 over a 5, and you get them right. Let's peek over at what's going on in Hong Kong, which is one of the countries that does quite well on these exams. Fill in the boxes with greater than, less than, or equal signs in each of these cases. This is not a multiple choice question. In each of these cases, comparing 1 to 10/10ths, a 5th and an 8th. Same grade level, by the way. 3/11ths and 9/11ths, and 2 over 2 and 2. There are ideas in this problem. The idea that a whole number is a fraction is part of this problem. Let you reflect a little bit on the math here. What I want to show is, to some extent, what has happened over the last few years. So before Common Core, the coats, and then the Hong Kong is in the upper left. 2 tests that were created to assess mastery of the expectations in the Common Core. We don't have to read the details of them to see that even on their face, they look more like the other work. Finding 3 fractions that are each less than 2/6, dragging each fraction to the correct location on a number line. These are more about fractions as numbers, fractions with a magnitude. They're not just about fractions as pictures or as slices of pizza. It's hard to multiply slices of pizza, it turns out. And so it's worth it to invest in a number sense of fractions. Hong Kong was one of the countries on which we were able to model the Common Core. So that's some picture of before and after. The question, what does it mean, inches us a little closer to the animating question about the liberal arts. But I'll start just a little bit with what it means for teachers. And as President Falk mentioned, my organization and I work with teachers to help them understand these expectations and implement them well. One thing it means for teaching is that the expectations for teaching have gone up. If I could commit the cardinal sin of a PowerPoint and back up. One feels one knows how to teach this, the standard algorithm. Helping a student understand that a digit in one place is worth 10 times as much as that same digit in the place to its right takes longer, takes some better curriculum. And of course, we need a wealth of rich word problems with a lot of variety so that students don't just learn tricks for those things as well. So the expectations for teaching have gone up. Let's look back at these 2 fraction problems. The one pre-Common Core versus the one Hong Kong. I can imagine that when your job depends on producing students who can produce right answers to a problem like the coat problem, we can easily enter a training mentality. Well, take the number they want and put it on top and put the total number on the bottom. Students often think of fractions as 2 numbers instead of 1, and why not? There are 2 numbers in a fraction. You won't get the Hong Kong question right by a training model like that. The Hong Kong question really does require that those 2 numbers coalesce into a single value. So the expectations for teaching that go up. I think it often happens, has often happened in the American math curriculum that a training model appears to be the most efficient way. And so what that means is, here's a snapshot of the student's brain after a steady diet of that. It's a lookup table. Oh, when I see that problem, I do this. When I see this other problem, I do that. If we had infinite memory, a lookup table approach would be fine. But it turns out that there are too many problems in math for a lookup table approach to work. We don't just need a long cash register receipt in the brain of problems and their corresponding methods. It turns out, I think, we need some ideas. With ideas, you can solve problems that you haven't seen before. They don't have to be in your lookup table. I was reminded of this when I saw the email inviting us to this event. It's hard to say what the liberal arts are, even for one who used to teach them, and for one who was educated in them. But I did catch this part in the email: solving problems whose shape we cannot yet define. And I contrast that with the lookup table, which only works for problems that you've seen before. There's a lot to the liberal arts. As I mentioned, disciplinary excellence, which involves bearing down and gaining skills. That doesn't exhaust the liberal arts, though. One of the outcomes that we want is this kind of flexibility of mind. And that's one lens through which to look at the Common Core and to understand why the standards ask for things that state standards haven't always asked for, in addition to the things that they used to ask for. It's made the job of teaching more sophisticated, and everyone is going to have to help support that activity, from publishers to schools of education. I think it's a generational enterprise. And so when you see Common Core in the news or in your Facebook feed, or like me, in the letters that come home from the school in your kids' backpacks, remember this question: is math a liberal art? When I was leaving New York City, I printed out copies of my slides so I could make notes on the plane, and I stopped into a cafe to get a cup of coffee, and I put the slides down, and on the cover was that question: is math a liberal art? And I noticed the person who was making the coffee kept cheating her eyes over to look at it. And finally, when I paid, she said, "So what's the answer?" And just off the top of my head, I said, "It is if we want it to be." And I think that's the best answer I have. Thank you.